Is about inverse game theory. So we have already discussed about the game theory in my previous video. So that game theory is basically used to understand the dynamics of a game to optimize the possible outcome of its players, right? So that, for example, in the prisoner's dilemma, that Nash equilibrium. In contrast to this, the that is game theory. Inverse game theory designs a game based on players' strategies and aims. So it is key to designing AI agents environments. So in standard game theory, that is the same thing, whatever that I've discussed here. So I've tried to uh, put it neatly in this way. That is in standard game theory, what we call the forward problem. So the rules and the payoff instructions, they are already fixed. Okay, so rules as well as the payoff instructions. Payoff in a sense, the reward, they're already fixed. We analyze these rules to predict what rational players will do and what the final outcome will be. That is the, for example, the input rules and the payoffs are fixed, whereas the output, that we have the strategies and the outcome. So already the rules and reward functions are already fixed. So we analyze these rules, then actually we predict the basically the what the strategy and the outcome would be. So that's what actually we predict. So it's always the forward problem. From the rules, you just design the strategies and the outcome. So rules to outcomes. So it's a forward problem. Whereas the inverse game theory, what happens here is that just the direction is changed here. So initially, actually, we start with the desired outcome. So what outcome we have to get? So we start that one, and we just work backward. We work backward, and then we design the rules and the payoffs. So it actually rational players acting in their own self-interest, they will actually innovate to produce the specific outcome. So we actually decide about, so what is the input here? The desired outcome. We have to understand the desired outcome, what is the expected outcome, like that way. So based on that one, we are going to work out the rules and the payoff, so that finally we get the specific outcome. So what I meant was that, so we start with the desired outcome, then we start with the desired outcome, then we this is what we start with the desired outcome, then actually we uh, bring out the rules and the playoffs, rules and the payoffs. Then finally we uh, produce the specific outcome. So this is like a backward strategy. From desired outcome, you design a rules and payoffs. Then actually again, you finally achieve the specific outcome. So one good example for this one is the GAN, Generative Adversarial Network. It's a machine learning model in which two neural networks compete with each other to become more accurate in their predictions. So what is this one we shall discuss. So what two neural networks is basically, this is an architecture of GAN, this diagram, and two neural networks is, one is the generative model and this another one is a discriminative model. So basically it has the latent or random variable as an input for a generator, the real world images, and then the sample is taken, which is compared by the discriminator. Then it is real or fake, that is what is going to be decided. Then finally the loss function is computed, which is going to update the discriminator of the generator. That we shall discuss all these things in detail the next slide. But the overall architecture of the GAN, the main two neural networks which compete with each other are the generator and the one is the discriminator. So these two things are the main components of the GAN network. So what is that one? So the two main players, as I said earlier, one is the generator, which we call that one as the forger. Its job actually, why called forging? Because it to create the fake images, right? Its job is to create the fake images that look so real that it can fool the other player. So what is the role of a generator is to create the fake images. For example, in the diagram whatever that is discussed here, it actually takes the latent random variable. So mathematically latent variable is just a list of random numbers like this one, but you can just conceptually think of it as a digital DNA or some receipt for the image. So something whatever the image which the fake image generator is going to design, so that actually this latent random variable which provides an input, so that actually the image can be generated by a generator. So the digital DNA or the receipt, no, not receipt, please apologize, I apologize for this one, it's a receipt. So recipe for image, and the processor processes it output a sample that is a fake image. So basically generator takes the latent random variable, some random numbers it takes as an input, so that fake image is generated here. So here a fake image is generated. So it's a recipe for an image. uh, so random variable, it's a recipe for an image which is given to generator, and generator generates a fake image. Next one is a discriminator. So discriminator, his job is to look at the images and decide if they're real. Okay. So here actually the real world images are given, one sample is taken. So here fake image, here real image. So these two things are compared by the discriminator. So discriminator's job is to look at the images and decide if they're real or not by comparing. Okay, real means from the actual data set. The email image. So real image that you get from the uh, actual data set. Yeah, sorry. I was just saying that actually the discriminator basically decides. He just looks at the images and decide if they are real from the actual data set that we get, or fake from the generated by the generator. So it just actually takes the images, the real and the fake, and decides whether the image is fake or real. So in the diagram, actually, that's what I mentioned here. So it receives the input from the two sources. One is the real world images, the gold standard that we take from the actual data set. Another one is the generator sample, that is the fake image. So these two things are the input for the discriminator. So what is the process that we have it? So follows the arrows that we did in the diagram. So basically actually setup. First one, the database that we need to have the real world images. That is what the photos of the real faces that we have it. I'm just going to explain the diagram here. Next one is the generator takes the random noise, that is latent random variable, and tries to paint a picture. Okay, it generates a fake image from the random noise. And the test, this is the important thing, the discriminator picks up the two images, one real photo from the database and one fake photo from the generator. It doesn't know which is which. Okay, so real image it takes it, and then fake image it takes it, but it doesn't know whether this real image has come from the real world data set and the fake image has come from the generator. So that discriminator doesn't know. The job is to discriminate, so it should not know that I have come, that real image has come from the real data set or actual data set, and the fake image has come from the generated by the generator, right? So that is what is the judgment. The discriminator looks at them and outputs a worded green. Green is basically real and red is something fake. So that is what we have it. So real means this is real, and this is means fake, that is red. Red is fake, green is real. So score actually, so what is the score? That is the loss. So right, this is one. What is this one? That is basically if the discriminator guesses correctly, the identifies the fake as fake. Okay, it gets points. Means that is low loss, and the generator loses points. That is high loss. Means generator is not able to deceive the discriminator. If the discriminator is fooled, thinks that the fake is real, the generator gets points and the discriminator loses. Means here generator has fooled the discriminator. So what is that learning loop that we have it here? So the box label loss is the most important part here. It acts as a teacher, right? So what does it do? It's feedbacks for the generator. The detective caught you. When your image was too blurry, the sharpness needs to be improved, right? So there is a feedback for the generator when the detector has detected the image as fake here. So generator actually adjusts its internal math to make better images next time, so that next generator can make the fake images look more real. So that actually teacher actually gives the loss actually function that actually gives as a feedback to the generator. So generator adjusts its internal math function so that the fake images look more real. Whereas what is the feedback for the discriminator? When if discriminator is not able to catch the fake image generated by the generator, then actually it says that gives a feedback for the discriminator. So discriminator adjusts his internal math to become a sharper critic, so that actually next time it can um, differentiate between the fake image and the real image in a better way. So this is about the GAN architecture. Hope all of you guys understood from this one, right? Thank you.